Okay, let's go over this. We have a tug of war going on. So we have a couple of people here all holding onto a rope on the one side. Over here, a couple of people holding onto the rope. Okay, and so we had group A and B, and we're told that group A is able to pull B, and so we have a force F equals, what was it, 1100 newtons. That's a zero. Newtons and newtons. And they pull group B a distance of 2 meters. And so both of those are in the same distance. I can't really draw them on top of each other. You wouldn't see it. If I do that, we see that the angle between those two is 0. And so we have work equals FD cosine theta. And so that's a force of 1100 times 2 meters times the cosine of 0 degrees. Cosine of 0 is 1. And so we have 2200 times 1 is just 2200 joules for the amount of work that group A does to group B. Okay, so that's number 1. Number 2, we have somebody going up an elevator with their belongings, and they've given us the weights of the belongings. So we've got an elevator attached to a string. What's important is we've got a person standing in the elevator with a head holding a box of belongings. And so the elevator is doing work on the person. And so the elevator is applying an upward force to the person equal to the combination of the weight of the person, which was 685 newtons, plus the box of 915 newtons. That's a very dense box. It gives us a total weight of 1600 newtons. And again, in the same direction, we have a distance of 15.2 meters. And so because they're in the same direction, we still have an angle of 0. So work equals FD cosine theta, and so that's 1600 newtons times 15.2, and the cosine of 0 is 1. And so the total work done by the elevator in bringing the person and their belongings upward is 320 joules. Now then the elevator lowers the person down. It is not applying a downward force to the person. Already gravity is applying a downward force. If that were the only force, they would accelerate at 9.8 meters per second squared. The person is going down. D equals, 15.2 meters. There is still an upward force, now only on the person, of 685 newtons. So we're looking at this angle here. That's 180 degrees. And the cosine of 180 is -1. And so our work is equal to force. That's 685 times 15.2 times the cosine of 180. Cosine of 180 is -1. It's just going to make this negative. And so the work done on this person is negative 10,412 joules. Okay. One person did it as energies, change in gravitational energy, which still works, but you need to do final minus initial. Okay. The person had, when just the person is, I think it's 6 stories up, 15.2 meters up, their gravitational potential, mg is their weight, that's this, times the height, gives us 10,412 joules of gravitational potential at the top. When they're back on the ground, they have 0 because their height is 0. And we do final minus initial, okay? 0 minus the 10,012. So both ways do work, but make sure you are still doing delta is final minus initial. Number 3, we have a truck. Let's see if we can draw a truck. Our truck here, and our truck is moving in this direction, V, right? V is, of course, not part of our problem, but if it's moving to the right, its displacement will be to the right. And we had a D equal to 850 meters. And the truck is slowing down, so we have friction applying a force to the truck from the road, and that force was given as 3,000 newtons. Again, I've got 180 degrees, and so cosine of 180 is negative, and our kinetic energy is leaving the truck, being converted to heat in the brakes, and maybe the road and the tires as well. And so work equal to FD cosine theta. And so that's 3,000 times 850. Cosine of 180 is negative 1, gives us negative 2,550,000 joules. So that much kinetic energy was turned into heat. Okay. Last one, number 4. There are a couple things that are tricky in 4. Okay, we've got an escalator is bringing somebody up, and so our displacement is at an angle. Okay. We were told that the person has a mass, m equals 75 kilograms. Well, the escalator needs to apply an upward force on the person equal to their weight. And so Fw equals mg, so we're talking 75 times 9.8. And so the force weight that the escalator needs to match, because that's a force from gravity, G, 635 newtons. So the escalator is applying an equal force up, because they tell us the person's moving at a constant velocity. And normally we would need to find this angle and take the cosine of the angle. But what that does is tell us how much of this distance the person travels, how much of that is in the direction of the force. Well, in the problem, they say the person has a vertical displacement, goes upward, a height displacement in the vertical equal to 4.6 meters. So they've done that for us. If we take this distance times the cosine of this angle, we get this number. They gave us a number. So all we have is, work equals force times distance. In this case, that this distance and this, the angle 0. So they've already done that total distance times cosine to get the 4.6. And so our work is just going to be, I'm messing up. This is part B, really. What did the escalator do to the person? It applied an upward force of 635 newtons, and the person went up 4.6 meters. And so the work done by the elevator is equal to 3,381 joules. Now, at the same time, gravity was pulling downward on the person. And so, sorry, for part A, okay, gravity is pulling down, the vertical displacement is up. And so again, we've got a 180 degree angle here. And so we're going to get negative here. And so the work done by gravity is going to be negative 3,381 joules. Okay. Sorry, I screwed the order of those two up. So it's still the angle. They've just given us the cosine, this distance, what we don't know, times the cosine of this angle we don't know, equals this. Okay, so they've done that for us. So we only had to work with the vertical displacement. In the case where the work done by gravity, well, in this case, gravity is pulling down, but the thing goes up. That sledge that I dropped, when it goes down because gravity is pulling it down, it's converting the gravitational potential energy into heat. It's doing positive work. Okay, both things are in the downward direction. All right, there will be a Zoom today. I will schedule both of those momentarily.